Alright mate, let's really get into how the internet works using a train system. First thing first, computers don't understand names like youtube.com. They speak in numbers, specifically IP addresses, which look something like 142.187.238. Imagine having to remember that for every website. Impossible, right? That's why we have the DNS, the Domain Name System. It's the internet's giant address book that translates the easy names into the numbers computers need. So let's draw the DNS. Just a simple rectangle for a station's departure board. Inside, let's write YouTube. An arrow, then platform, IP address. This shows exactly what the DNS does. It links the name to the platform number. Okay, so we have the addresses. Now, when you ask for a website, the data is, is not sent as one giant file. That would be inefficient. If there was a one tiny error, you would have to send the whole thing again. Instead, the data is broken into thousands of tiny numbered pieces called data packets. Let's draw these packets. You see? We'll just draw a few small squares. Inside each one write a number. 1, 2, 3. And so on. These are our passengers, and each one knows its own seat number. This is crucial for later. Well, now, how do these packets travel? They get on train, which represents our router. Your home Wi-Fi box is the first local station, but the internet is a massive network of tracks and switches connecting countless routers worldwide. Each time a packet moves from one router to another, it's called a hop. Let's draw our train. A few squares connected together is perfect. Now put our numbered packets 1, 2, 3 inside the train. Underneath, let's draw a network of intersecting lines for the tracks. At the intersections, draw little V shape. This is our switch. This shows how routers guide the train through the complex network to find the most efficient path. Finally, the arrival. Because of the complex network, the packets might take different routes and arrive out of order. Package 3 might arrive before package 1. Here you go. This is where their numbers become vital. A protocol called TCP acts like the station manager at the destination. Its job is to reassemble the packets in the correct order. Let's draw the final scene. First, draw a long rectangle for the destination platform. Now let's show our packets arriving out of order. Draw package 3 on the platform, then 1, then 2. Draw a station manager figure pointing at them. Finally, draw an arrow from the jumble group to a perfect ordered line of packets 1, 2, 3. And that's it. The DNS finds the addresses, the data is broken into numbered packets, routers guide them through the network, and TCP puts them back in order. That's how the website appears perfectly on your screen. Cheers, mate.